Okay.
I read the other book, the Lisp, by Pieces, I think.
Lisp in small pieces.
This is small pieces, which by the way is a anagram for like Lisp. It's recursive.
That's cool. That's cool. Okay, so the only thing that matters is kind of like this. So this is like long story short, Mageta. Yeah, everything else you already know because it's basically talking about how to program in C. What really matters is this, which is the execution loop, which is basically printing stuff from the terminal and grabbing the input from the user. And in this particular instance, doing a printf, and that's it, with your input, of course.
Oh, let me turn this on.
And it's showing how to compile. It's showing how to. Oh yeah, it's not using RL wrap, right? So it's
Mm.
using a custom Windows cross-platform history mechanism, which is why just use RL wrap, man. It's just a lot just easier. Anyway, so then we go to chapter 5, which goes to a parser combinator library that he made in C himself. And yes, it is generic, although you need to be very ooga booga and provide a number of parsers.
Yes, like good seeds, integers, right?
Yeah. Uh, and then at the end, like is all cool and all, and then at the end he just says, you know that you can just jump it and just put a full blown grammar, and who cares?
Mm-hmm.
So this is basically doing all the work for you. You don't need to care about parsing at all. But
Ah,
then I thought, I was very naive because then I thought, okay, so basically gonna write this, and he's gonna make all the parsers internally. So he's gonna make a parser for numbers, for instance, to like from 0 to 9 characters using an OR. But I was wrong, because if you go to chapter 6, where he's actually parsing expressions now, we are not
Mhm.
only
Yeah.
parsing whatever. Like he was parsing English sentences, right? So now he's parsing
Mm-hmm.
actual expressions. He's using regex. Like, what a
I was gonna
big
ask.
brain.
I think he didn't explain yet, right? He might, because the difficulty I have with like parsing Lisp is that I know like old parsers they do like they parse quotes. Sorry, no, they parse just like three things, right? Symbols, numbers,
Yeah,
strings,
yeah, yeah.
and some special elements,
Mhm.
right? To
Very
build the list.
specific set.
And then they deal everything with cons, right? I really don't know what to do that because if you recall our parser from what's the name of the language that we did?
Oh,
Silverware.
the two silverware ones. Yeah, we
Yeah,
did
it was
combinators
very
in both.
bloated. Yeah, it was very bloated, right? Because we parsed a lot more than we should
Yeah,
have.
so the
So
lesson that we learn is that parser combinators they don't scale very well because as you start to have ambiguity, you need to
yeah.
get rid of it. Starts to get a lot harder to get rid of the ambiguity as the language increases in size,
Mm-hmm.
which is very
wait.
fair. Like it's what convinced me that Nathan was right that we should consider generators instead. Uh, but even then, he's doing very simple stuff. So I'm very curious, and I really wanted to see the code for this, and unfortunately didn't have the time. Is this really the best way? Like in just implementing, because remember he's gonna have to parse this internally
Mm-hmm.
to make this
Mhm.
regex, and then the question is it is he transforming this to MPC or parser combinator with the chars 0 to 9, or he's just, shouldn't it be easier to just use regex with a library from C? So I don't know the
Um,
answer to that.
it's probably doing what you said, like turning it into an OR. Uh, because I think it's mentioned in the previous chapter, but MPC actually uses MPC itself to implement this
Yeah,
grammar.
yeah. It's recursive. Yeah.
So it's kind of self-hosted like that. And the straightforward way to do it when you are already self-hosting a thing is to continue self-hosting it. So like, yeah, the natural way to do it, and I'm guessing that's how it's implemented internally, I haven't actually checked, would be to turn it into an OR from MPC itself.
Yeah. So
Um,
so 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 So
There
here's the
might
kick. He basically is parsing this for us, and it's like two layers of indirection, right? So you have, oops. So you have the parsing that we was doing before, which is parser commutators all the way. Okay, nice. Then he's developing another grammar description language, which is this thing, and then he's parsing that, and we never see that happening. For us, it's completely transparent. Like you see that we are getting okay that he says that in the book, right? He's treating as a black box. In chapter 8 he says you need to get intuition and you need to have faith that the implementation is right. You need to trust me.
Literally me working.
So it's kind of like, again, I really want to see the code for this, and I'm very sad I didn't manage to do it. Anyway,
um,
Do they have like source
personally,
from the book, by the
oh
way?
yeah, um,
Oh yeah.
let me pick that for you. Uh,
uh, just a quick comment about Lemos asked earlier if he thinks this is the best way to do it for parsing Lisp specifically. Um, as someone who very much likes Lisps,
Here it
um,
is, Magita.
Oh, thank you.
Here, all the
well,
code.
Can you still
I
hear?
would.
I'm gonna send in
I can hear. We can hear you.
the thing there.
Thank you.
Yeah,
Go, Marin.
yeah. So first of all, I wouldn't use a general context-free grammar. I would use a peg grammar
Yeah.
because it's not
We talked about
ambiguous.
that.
Um, and secondly, for a Lisp specifically, I may forgo a library entirely because the grammar is so simple that you may as well just do it by hand. Like,
Yeah,
there aren't very many things to keep track of.
I think that's fair. I think that's fair. Although I don't know if it would be. I don't know how far we're gonna go. So maybe this is like foreshadowing that we're gonna go very far. So he made an entire parser library because he understood that, okay, doing this the easy way, like the by hand way, it's possible, it's doable, but for an amount of stuff that I want to teach you, it's not practical. It's gonna take up like hundreds of lines. So maybe there's a reason. Because that we need to remember, right? So our parser for a simple stack-based virtual machine is taking 200 lines. Just for that. So imagine a
But
full-blown
a,
Lisp with macros and whatever.
but a Lisp parser doesn't have to care about macros. It only has to care about
Mm-hmm.
reading symbols, reading lists, and reading other kinds of constants like numbers or strings or
Mm,
whatever.
Mm-hmm.
The
okay,
fact
I
that he
didn't think
went
about that.
all the fact that he went to all the trouble of using a library that would spit out a full-blown AST with annotations and stuff.
Oh yeah, I
Um,
want to talk about that. I want to talk
yeah,
about that.
that tells me that first of all, his Lisp is going to be very different from a traditional Lisp, which is fair. He mentioned that at the beginning, like on chapter one, I think there was a disclaimer about it that
And if you want
uh,
to go into war with him, he doesn't care. So
yeah, this is called build your own Lisp as well, right? It's in the
yeah,
title of the book. It's his Lisp, and he encourages you to make your own changes to build your own Lisp as well. So yeah, it's different, but that's fair enough. It's his own Lisp. He can do whatever he wants.
yeah.
Um,
Let's talk about a little bit about what you said before, because I think the first time I saw this, I like, man, this is very cool. This is telling me what it matched with, and this is very convenient because this is like easy debugging, man. Because
yeah.
when you're doing parser combinators and you don't have the ability to log this kind of shit, you're gonna have to guess at some point because you have so many stuff that you are put in the language itself. So this is very cool that you can see what the thing tried to match with. That's very interesting. Um, okay, so anybody else? Do you have any other thought about parsing? Sorry, I think it's fine. Like I think it's fine.
I noticed one small peculiarity. The very outermost expression is not parenthesized.
Um,
I'm
you
not sure
mean
if you
this
noticed
expression?
that.
Yeah, it makes
Yeah,
sense, right?
there are no parentheses around the
Oh,
entire thing.
Yeah,
Oh,
but this is only on this case because when you go to evaluation, we're gonna have to remember that there is a token that he's jumping tokens hard coded, but he's jumping parentheses. So I think this is only for this particular case.
I would understand, like, for example, what I thought when Marinho said was like, if you type just a literal, right, on a list prompt, like a string, it's just evaluating into itself, right? It's just
Yeah.
that. Or a symbol or something like this. So I think that would be possibly what he was going for. But it's kind of weird that the expression with like because it's like a function call in that case, like
Yeah.
function call. Although the
Yeah.
plus is not a function or a multiplication, it's a plus.
Yeah.
Yeah.
Another thing that another thing that I noticed is that at this stage, at the very least, if you look at the grammar, you see that um, when we have an operator, the
Grammar.
operator is specifically one of those particular symbols, right? It's not
Yeah.
a full-blown
Yeah.
expression, so that's
Mm-hmm.
something to keep in mind,
No.
at least for now.
Yeah, that's something to keep in mind. That
Yeah.
for sure, for sure.
He will expand it.
He will definitely extend it. We're gonna see that next chapter here, chapter 7. Yeah, so here is where I have a few questions. So this is basically his type, right? This will definitely be an ADT
Mhm.
if you're doing any sort of functional language. Uh,
That's not the Lisp way, but as I
yes,
say, disclaimer at the beginning of the book,
yeah,
whatever.
but can somebody tell me why this needs to be a pointer of a pointer? Like,
Um,
is there
because
any
an
reason?
array, there is actually. This is a pointer to an array. Like, this is actually an array of
Mhm.
pointers, but a pointer in C is literally, oh, I mean, an array in C is literally just a pointer to a region of memory that has more than
Yes,
one value of that type.
yes.
So an array and a pointer are basically the same thing in C.
No, yes,
You can
but
read this.
when you see the pointer of a pointer in this case, what do you read? You read an array of arrays?
No, I read it as an array of
Yeah.
AST pointers. The AST pointer has to be a
Yeah.
pointer because this is a tree, so the pointer is kind of like a link to another node.
Mm-hmm.
Oh, I think I see. Okay, okay, so that
If
answers
it
one of my
was like a
questions.
normal like Haskell, it would be just like one pointer, right? Because it
Yeah,
would be just
It,
this.
yeah, in Haskell, the signature for this would be a list of AST, basically.
Mm-hmm.
yeah, definitely the case, definitely the case. So the point of the pointer is basically the way to say a list of a list in here.
Actually, a list of
Yeah,
nodes.
because you
A
need
And
list
to
of
because
nodes.
node,
allocate each node, right?
List
So
of
each node
stuff.
is a pointer.
yeah, each
Go.
node is a pointer, and you have more than one of them. So this is an array, which means there's another level of indirection there because an array is treated as a pointer that points to many things instead of just one.
Yeah, list of nodes. List of nodes.
List of nodes, indeed.
Okay, Joe, you wanted to say something?
No, no, no. You're right.
Okay, then we go to the. Then I think this is where it starts, like to show that C has a very shallow level of high level abstractions because this is where we have a bunch of memory wasted for stuff. And this is not the worst. The thing that happens I think next chapter is the worst, which is when we need to identify, oh, we had an error. How to do an error? Uh, that thing is not is
Mhm.
like,
What
if you want to be pedantic, you can even like combine the string pieces of informations with masks and shifts and blah. No, 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 no. He just said memory is cheap. Go buy more memory. F you, man.
the problem is not even that actually. Even if you give him that argument, okay, memory is cheap, fair. He's still being wasteful anyways, even beyond just that. Like when we when we get there, we will get there, and I will
Yeah.
have some things to say. But let's continue.
Okay, so what is cool here? This is what I mentioned last chapter. So this is where it's showing us what's gonna try to match during the parsing. So this is very useful for debugging info. And then he's explaining that we have the list of nodes, etc. And you can access it via indexing. So this is basically this is basically printing everything on the screen. And then he says that an expression has other expressions within, which means that we need to recursively evaluate this thing. Although he doesn't do that. right? He's using well, he's using a recursion, yes, but it is not like there's a for in the middle. So
And
you are
that's because
recursing
he's
each child of the children thing.
yeah, that's because the recursion is not quite direct. The recursion is, I think the term for this in Haskell is polymorphic recursion, where like instead of the thing containing another copy of itself, it contains another type that is parameterized by itself. So
Yeah,
it's not that the node contains another node, it contains an array of nodes.
yeah,
And
yeah,
the way
yeah,
you
yeah.
deal with arrays in C is with loops,
Mm-hmm.
so that's what it does, which is fair, I guess.
And this is basically doing like traversing the tree. So if you reach a leaf, which is very common practice, like, and I didn't mention this, but this thing is basically measuring this. But instead of you every
Yeah.
single time waste time calculating the size of this yourself, you just have a counter that goes with you along the way. Very very C thing, a very very common C thing. Then
Um,
he checks if the we are done in this level, and then he just returns one. And if it's
by
greater
the
than
way,
one, we just go to each children and do the same. Yeah.
did you notice anything missing there in this function?
This particular one,
Yes.
um,
Where is the
It
no
doesn't
check?
change the number
go Mac, go.
in the
Like,
struct. In the function he calculates the total, but he doesn't change the value on the struct itself.
no,
Wait.
that's okay. He's just counting the nodes.
Oh no,
I
he's
I
not
don't
saving
think.
that information. You were right. He's just throwing it out. So he's not
Mm-hmm.
saving that anywhere. You're right. You were definitely right.
No. Yeah, that is true. He's not mutating anything. He's just returning the total. That's fine, I guess. The problem is it takes a pointer as an argument, but it's not actually checking that the pointer is not null. That's missing.
Oh, it's
Oh.
Mm-hmm. Mm-hmm.
yeah. So if you throw nu at here, it's
Mm-hmm.
gonna just gonna f you in your face like for days. That's true. Both are true. So what Max said is true. He could pick this total and just put the t child num equals total. He could do that. He could have done that,
Um,
and he also is missing the checks for the null pointer. That's completely true.
Just
Actually,
a comment.
if he wanted to write the total, he would have to add another field to the struct because children num is specifically used, at least in this context, for bounds checking the array. And it's not like the array has like 34 items if you have a deeply nested expression,
Oh,
right?
okay, okay. So Marinho is right. So I was confused. So the children num is only one level of children that you have. If you have more,
Mm-hmm.
because you are like grandfather and grandfather and so on, you would need, yes, another field to know that amount of information. That's true. That's true. Okay, then he's basically explaining how recursion works. Uh, and now he's basically he's gonna use a bunch of conversions from string to numbers in order to do calculations with the arithmetic operations that we have available. So this is where we definitely see the parentheses, I think. Because if you take a look, the operator is always children 1. And I think that's the reason for that is because children 0 is always the parentheses.
Yes, that is the case.
Um which means that only at this stage he was supposed to check that this toy will not break in your face. Right. So the parser is completely unaware of the real representation of the things. Everything is a string. Everything is a string. Like that sounds familiar. That sounds familiar. Like JSON, people using JSON for everything, for instance.
Um,
Um,
I don't I don't have a problem with that in and of itself. I do have a problem with doing that in C because of how C strings are represented. That's not really ideal.
yeah, but shouldn't he have done the check of this should be a number before going to, because this is basically evaluation. right? This is runtime evaluation
Mm-hmm.
time. So only
Yeah,
at this stage he discovers that.
yeah, that's a problem. This is another thing that's not really Lispy at all. He's completely mashed together read and eval. Like they're not separate things
Yeah.
here.
Yeah, exactly. The read and eval, they are like it's basic. The read is very primitive, so it doesn't do any checks, like anything. The only thing that it can break, I think the parser will complain, is if you don't have the, I don't know, you're missing a closing parenthesis. So maybe the parser will complain about that. But if you have
It
the
will.
parenthesis, but you have bogus stuff, you're trying to sum two strings, it's gonna only the evaluator is gonna be able to say something about that. So the
And
I
parser,
again,
mean,
he doesn't check nulls. Just
yeah, and he doesn't
I
check nulls,
mean,
of course.
he doesn't check those. I mean, the whole like checking that if you're adding two strings, to be fair, that it would be checked at runtime in any Lisp basically
Yeah,
because dynamic typing. But um, you would know statically that there are two strings being passed as an argument to a function that's being
yeah,
named by a symbol.
yeah,
You may not know what the symbol is ahead of time, which is why dynamic checking happens, but you do know that those are numbers. But that's not the case here, right? He's
yeah,
deferring the actual deserialization until runtime as well, which
yeah.
it feels wrong.
Yeah, that's actually another way to see it, right? It's almost like this is very, it's not, it's serialized. It's serialized data. And you only do the deserialization process when you were evaluating it, which is like crazy.
It's lazy evaluation taken to a very unhealthy extreme.
Okay, so he's basically grabbing the operator because you're gonna need to do something about that, and then he's grabbing the first expression, right? And why this is an eval? Because this can be another expression within itself. So this can be another plus or another multiplication, doesn't matter. Then he makes an eval op, which basically means apply this operation to this guy and the result of this guy, and of course this guy also can be an expression within itself. So we need to call eval here as well.
Eh,
Yeah.
Yeah, this loop is basically just a left fold.
There we go. One line. The entirety of this is a left fold. Cool. Then we have the eval p, which is basically doing a match on the symbols and then just doing the respective operation. And yeah. Okay. Then he is showing how to do how to get this to happen in the thing. And I was wrong. Actually, the first expression can be with still can be without parentheses. Look at that.
Uh, Fun fact, back in the very beginning of Lisp, there was actually a little bit of debate on what should the exact behavior of the REPL be, because back then, people still hadn't decided if they wanted the REPL to be based on eval or on apply. This is an example of a REPL based on apply. You don't need to parenthesize the outermost expression.
That's very interesting.
I think they were copying Smalltalk, right? That was the inspiration on that approach, I think.
That's backwards, actually.
Okay, so
Smalltalk
No,
Smalltalk is
is
inspired
inspired.
Smalltalk came
by
before.
this.
Smalltalk is inspired by Lisp. Yeah.
No, that's the opposite, is it?
No, it is. Alan Kay actually specifically mentions that in a brief history of Smalltalk that he was reading the Lisp manual and he called it the Maxwell equations of software.
Lisp is from 60.
No, it's from the 50s. It's the second
It's from
oldest
50s.
language.
It's 50s. It's 50s.
Okay,
It's
so
the
that's
sec-
right.
It's
I
50s.
thought Lisp
it's
was
the
from 60s or something.
No, it's from the 50s. It's the second oldest language still in use. The oldest is Fortran, by the way.
No, of course.
Yeah, but my question
Well,
is,
Go ahead, you.
go ahead, Joe.
oh, sorry, but I was reading the code again here, and I believe we are wrong interpreting that. Uh,
Which one?
you see, when he looks into the children, he takes children one, index one to be the first useful thing, right?
Yeah.
And we are reading this as there is a parenthesis in index 0, so we are just ignoring that opening parenthesis. But it is not the case, I believe, because if I remember well, if you go back a little bit in the book, the first
Are you
thing
sure?
that's yeah, because just a little bit more up into the book, this code that's showing here, the first thing that you can see here is this rejects object. It's in index 0.
I
This
I
is
don't.
why he's ignoring that.
But he's saying he's the second child because the first is always parentheses.
I
Am
think that's an accidentally correct. I think this is a case of an accidentally correct code.
Yeah.
Wait, I'm still confused with what did you said. You said that there is a rejects thingy, and this is where is
Yes.
where
Yes.
what is in the zero. How come?
Let
Maybe I need
me
to.
double check the grammar.
Okay, because
Let me
for
double check the
I
grammar.
was very sure of that because of this line here. And the final child is always parentheses. But very cool that
Um,
Marinho pointed out that this is an apply based REPL. I didn't think about that.
An apply base REPL. What does that
it's a
mean?
RAPL instead. Read apply print loop.
Yeah. What that means is that
Mm,
instead of assuming that everything is that the first thing that you're gonna do is an expression that you're gonna evaluate, you're gonna assume that the first thing is an application. So
mm.
then you don't need parentheses, I guess. Does that make sense, Marin?
Yeah, because apply takes a function and a list of arguments, and it applies the function to that list of arguments.
Yeah.
So
Yeah. So it's basically
But he's not dealing with Lisp expressions yet on this stage of the book. He's only
no,
dealing
there
with
are no
arithmetic
yeah,
expressions.
yeah, there's no concells whatsoever to be seen just yet.
yeah, no, but this looks a lot more an expression, right? Yeah, like a normal expression.
Oh, there's a minus. There's a minus sign there.
Oh yeah, but that's why we are calling application based. Because why wouldn't it
Mm,
have an parenthesis wrapping these guys? And what Marin was pointed out that this makes it feel like, oh, you are picking a function minus and applying two things to it. You're not
Oh,
reading this as an expression.
I think I
mm-hmm,
see why why this is accidentally correct. The
Go on.
top level production in the grammar is called Lisp. It starts with a regex for the beginning of the string, and that's what's being matched
mm-hmm.
as the first starting, as index 0 in the top level.
Wait, so this is accidentally correct then? Is that
No,
what
the
you're saying?
fact that you
I
yeah, the
believe this
fact
is not being checked yet. I believe this is not being checked yet.
yeah, like the fact that the application at the top level of the REPL works is accidental because like he's assuming that he's going to evaluate an expression, but the top level is not actually an expression in the grammar. It's a Lisp. And the Lisp happens to have a regex as the index 0, as the child 0,
When
just
you
the
say
same
a
way that
Lisp, where can I see that? Which part are you looking at?
You have to go back in
go back to
the other
chapter
chapter, I
6,
believe.
the grammar there,
Mm-hmm.
at the middle of the page.
Middle. I am in the
Yeah,
middle.
right there. You see, there's expert, which is either a number or it starts with a paren, an operator, and expressions.
Yeah.
Um, that's where he says, oh, the first thing is always gonna be an open paren, so we ignore it, right?
Yeah.
But that's not what actually matches in the top level. The top level is a Lisp, which is the line below.
Hmm. Yeah.
Oh. Oh, that's kind of like a misplay then. Okay. 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 Yeah, I think that's fair enough. Thank you, Edu, to bring that up. Okay, now let's talk the error handling, which is hilarious. Uh.
We finally reached the place where maximum waste is happening. Like,
Ah,
What?
oh.
I don't think this could be any more wasteful if he tried, like
Yeah, no, it could.
deliberately.
Everything could be longs. It could be worse. But why he's not
Actually,
using a pointer, man?
no,
Why?
but actually, Actually, longs would be less wasteful
I don't think
because
so.
of
An
how
int
C.
takes less space than a long.
No. They would be less wasteful because of padding. You're not considering padding in the struct.
Ah, okay,
Yeah,
that's
the alignment of the fields.
ah. Yeah, but this is the perfect
Actually, if you
situation.
check size
Go.
off of int and size off of long, they are the same.
They're not
So
if you're in a 64-bit machine, are they?
Yeah, a long is
Like
is is not
I
the same
guess
thing. Go, Zeke. Mac, go.
I think we have long which are 64 bits, and ints are 32 bits. The difference I think is when using a 32-bit system.
Okay, I actually
I
don't
don't
know
know.
the answer to that. Does anybody know if long in 64 bits is actually equivalent in to 32 bits?
it might be compiler dependent actually.
Oh,
Yeah,
so
it's compiler dependent.
okay, so
If we need the exact bits number, I think we should use other. There is a header that defines each
Yeah,
list size.
FTP int, right?
I guess,
Mm-hmm.
yeah. I used it when working with STMs, and they're more precise than using int or short or long, because it is
Yeah.
very dependent on the compiler and on the platform itself.
now which file? Do you know which header that thing is being defined, Drew?
I will search
Which
for it.
thing?
This thing, this thing,
Which thing?
this thing.
This thing? It's check it. Wait.
Functions
It's
Error
on
parsing
handling dot
error handling.c.
error handling.c. Oops. Lval. Well, we want the kind of this. Okay. Yeah. Okay. So Mac was right. We should have he should have been more precise. To not be architecture dependent or compiler dependent.
yeah. But
Anyway,
like
that doesn't change the story. That doesn't change the story because for me,
yeah,
all of these should be pointers. All of these.
actually
Yeah, before that, do you guys would do something like other kind of structures to represent those operators on the chapter before?
it
Because
did
as you
you
said, he's taking strings and say, this is a plus, and then I should go straight to evaluating a function.
Oh, so your
You see,
question
he's
is
comparing strings. You
yeah,
see,
your question is
you see,
should
he's
we
comparing,
have another data structure to hold stuff
for example.
instead of just doing
Yeah.
this Ooga Booga way?
Yes. Yes.
uh well
What would you do?
Do you mean like
well
using
he would use
Elixir?
We using what?
Elixir.
No. He's talking. He's not about talking about changing the
Maybe an
language.
enumeration of
He's talking
symbols
about
to
instead
define
of
the plus
dealing with the things like
of
um,
the strings
yeah,
straight
on the string
straight.
level, he's suggesting to have some sort of intermediate representation of the data. So something happens
Yeah.
before this stage that organizes the pure chars, pure strings, in something more or more structured, like something that you can
Manageable.
actually trust a little bit
um
more. That's his question.
Ah,
actually I don't mind him using strings at this level just yet. Ideally this should be a symbol, but then he would have to implement in turning, which is a whole nother thing. um But while he doesn't have interning, symbols and strings are basically the same. They just would have different type tags. Again, he's not reached the level of having type tags yet, so there's that.
Okay, I have another question for
Um,
you though. If let's suppose that we
okay.
add another data structure to handle the operators with the numbers, what would be
Hmm.
the benefit of that? Because one of the things that I think about is that the if this structure exists, there are some checks that are already done. For instance, this check here.
Yeah, I was thinking about types, some kind of type checking, but it would
Okay,
be
so
kind
I
of
think if
primitive
that's
Yeah.
still.
the goal, because as Marin already pointed out, that's not the Lisp way. The Lisp way is just go burr, right? Just trust
Uh,
it.
the
But
real problem, the real problem here is that you don't have first class functions yet.
yeah,
You can't pass them as arguments. Like you can't have higher order functions just yet. In fact, you don't even have functions objects yet.
Yeah, but I
The
don't think Edu is talking about that necessarily, Marinho. I think Edu is talking about checking if this intermediate representation, if you get the intermediate representation, that already means that this is a 5 that was already pre-checked, you know?
Or this is a plus that I know it's a plus,
Yeah, you
and not
already have
another
some sort of,
funky symbol.
you checked some stuff previously. So that would be the purpose of this intermediate representation.
Yeah, you would have to. I think you can do something like that. Of course, the obvious thing is actually deserializing the numbers,
Yeah,
right? Because as a string, they're still in the serialized format.
yeah,
So that's the first thing. You have some implied checking has happened behind the scenes to give you a number. Otherwise, we would have errored out earlier.
exactly,
For the
exactly.
Yeah, and for the operator itself, um, I don't think you can do, as I said, anything more advanced than just tagging this as a symbol as opposed to a string, which doesn't even do all that much just yet,
I
because as I
agree.
said, you would have to implement in turning. Um,
Yeah, I agree. Yeah, so the answer to it, Ju, is that I think I would do it because uh, everything is concentrated in the evaluator so far, right? So if this explodes, it's in the evaluator.
Mhm.
The entire reinterpretation of all the deserialized data also happens here. So I think doing a little bit of checking before, although you are thinking that because you and I we are biased towards that approach because this is kind of like a primitive type checking,
Mhm.
uh, and this is basically trusted in Gobert. So anyway, so let's go back to the explaining what this means. So what this means is you're gonna create a type, right? So basically this means this informs you which one of the other two you're gonna look at. That's the first. Another thing that I think it's really important, and he introduces enums just for this, just to have a little bit of a notation instead of having just plain numbers flowing around,
Mhm.
is that we don't know. Like we know that we can tell you what's wrong, but if we're not gonna tell you where it's wrong. That's an important difference because let's say that I have something like where here. Let's say that this is in the middle of a very big expression. I'm not gonna tell you where is wrong. I'm just gonna tell you division by zero, right?
Yeah.
So this is like I don't. I'm hoping. My hope is that this is gonna get a lot better.
he's going to all the trouble of wasting all that space with an abstract syntax tree, and he's not even taking advantage of it.
No,
Like,
he's taking
why?
a little bit of an advantage because now at least we can throw errors before it would just explode. So I guess this is better, but it's not like a really like jumping improvement by any stretch of the imagination. Um, anyway, so I want to. There are a few things that I want to point out about this specific part of the code. This is really like where C struggles. This is really where C struggles. And again, if you want to go even more efficient, you can just combine them, right? So you can just make a single long number, and you use masks and shifts and combine them into a single thing. If you care that much about wasting memory, and some padding stuff
Like,
issues.
like, yeah. First of all, about the wasted memory. As I said, int versus long. There's some padding there that is being wasted. Second of all, you will never have a num and a ner in the same value. Like the type tells you that one of them is completely wasted.
Yes, I completely agree with that. Uh,
So wouldn't this be better to be like? The problem is that you would have to, in C specifically, you would have to mess around with bit shifts to properly
yeah.
encode this in a compact way.
Yeah, but there's something that I also didn't like. Now that I think about it, this is a number, and if the type
But
tells you that this is a number, you're gonna look at this thing. If the type tells you that this is an error, you're gonna look at this. But both are
yeah, you.
Yeah.
integers, so why don't you
Uh,
just use one thing and reinterpret according to the type?
yeah,
This
that's
is
the
why we
probably
have unions in C.
Yeah,
He
yeah.
can actually. user unit. For example, SDL2 used it for its event system.
Okay.
They actually check the type. Depending on the type, the functions, it is a hierarchy of many unions, and it is very memory efficient. I
Okay.
could use that.
Uh,
Or simply
yeah,
a bit set. We don't need a lot of information here.
Yeah. Hey,
yeah.
Drew.
I believe that he's doing this for simplicity's sake.
Okay. Okay. So with that, you're basically foreshadowing that this is gonna get better. I'm trusting. I'm trusting.
No,
And I- and and
I
and
don't
I need to
remember
be
if
fair.
it gets better.
If if I never, if I was not, if I didn't know what the heck
You
was
read,
happening in a language, I think this would be the more educational. Like people will get less lost this way.
yeah, but remember, this guy is targeting newcomers to see.
Yes. Yes.
He tells it in the introduction, so it's kind of fair.
Yeah, we should be fair. Like
Hmm.
just to say, like we know better ways to do this, so we are just saying it
Hmm.
out loud, but we're not criticizing the educational value of this because I think that
Yeah,
this is
no,
going to be
I
very
believe
easy to
it's well
newcomers
done.
to understand. Maybe the newcomers will not grasp the problems that we are already grasping, such what I pointed out about location, right? So the error only is going to say there is an error. Good luck with that. And
Mhm.
Mageta and I, and Nathan and myself, we know exactly that we should provide the location by experience, because in the beginning we did only throw in the error, and it was terrible.
Yeah, but
Um,
it introduces another level of complexity of
yeah,
on the solution, right?
yeah.
So
You
on the
now you
problem.
need to hold location information, which is another completely
Yeah.
different thing. Anyway, so then he creates functions to basically create numbers and errors, because now numbers, they are not numbers, they need to be within a struct.
Hmm. Yeah.
Okay, and then he's creating
Kind of a
enums.
type constructor.
Yeah, basically. And he's creating some enums to provide some more meaningful names,
Hmm.
uh, which is completely fair. And then now we the printing will also print, will be able to print error stuff, blah blah blah. Oh, and that's actually something that I was like minor details. I don't. This is not a big thing, but I want to point it out just because I thought about it while I was reading. Would you put the error messages within the print function, or you would put the error messages somewhere else? Because this can be very big, right? This switch case can be ginormous. And I don't really care
Hmm.
about it. I only want to change my error message. So my first instinct would be to have a separate header with only constant char stars with only the
Mm.
error messages, and the printfs would only call those global things. So then I can ignore the switch
Yeah,
case and
sounds good.
all the complexity that goes with it, and I would just customize my messages. I think that would be an interesting approach. Okay,
Yeah, sounds good. For a refactor, maybe.
now we are basically implementing what the short circuiting, right? The short circuiting. So if you have an error, you're gonna stop everything that you're doing, and you're gonna throw that out.
Mhm.
Uh, so this is basically like different languages that we have different approaches, right? So in F sharp or in OCaml, you would do a pattern matching. And I recently discovered that apparently OCaml has a special let bindings that I think you can do basically the same short circuiting as do notation. So that's kind of interesting. But in here, we're gonna just do a bunch of ifs because that's the level that we are right now.
You mean like let plus?
Yeah,
That's a PPX thing, I think.
yeah. I
Trust
know
me.
it's like dynamically generated, which is kind of meh, but it's better than just having 50 better matches chained together.
Well, Nathan said it's nope. It's probably a thing on the.
Okay, so it's not PPX. Okay, so that's better.
Oh, it's a function they defined named let. That's the thing.
So like Cameron and Haskell, this is basically a no-brainer. They have abstractions with this purpose in mind. So you want to short circuit your thing. You don't want to have to bloat your implementation just because of that. So then let's use something else. Maybe you can even use computation expressions in F# to do this actually. Maybe that's a thing. Uh, okay, but anyway, going back to C, you're just gonna check if now you are handling these special values, not numbers anymore. So you need to check if their type is
Hmm.
there, if you have errors, and if you have errors, you're gonna return X and do something about that.
Because X is an error.
Yeah, X is an error. And if you don't have any
Mhm.
errors, which means that both of these ifs are false, you're gonna do the same thing that you were doing before. You're gonna do the same thing that you were
Mhm.
doing before, and you are extracting the thing that matters using the .num here.
Mhm.
Um, and the division has a special case, which is that you are using the ternary operator to check if you have a division by zero, which means that the
Mhm.
y num is equal to zero. I think that makes sense.
I don't like the
Mhm.
fact that the ternary operator in C is called the ternary operator, as if it was the only possible ternary operator in the universe.
Isn't it in the universe of C? Isn't it the only ternary operator?
It's literally just an if expression. Why don't you call it that?
Because
Because
the
it's not an
syntax is
if,
different enough to
it's
have
a
a different name.
ternary operation. Yeah.
And personally, there are a lot of times, even in Haskell, that I miss this. I miss an operator
Oh
that does
yeah.
the if. I don't want to have to
But
Mhm.
write the
that,
if then else or when, right? This is so much more compact. It's not a semantical debate. It's an aesthetic debate, in my opinion.
Mhm. No, this is very beautiful. Yeah, I like it too.
I
Uh,
mean, I do like the syntax. I think it's okay for what it does. I just don't like that it's called the ternary operator. Is all.
okay, that's fair. okay, that's fair. Okay, then we
Also,
go.
quick note on the note there about the ternary.
Sure.
I'm okay with the fact that the author is pointing it out and explaining what it is.
Yeah.
I'm not okay with the fact that he says some people don't like this operator because they believe it makes the code unclear. I think that's an okay observation in general, but in an educational context, you don't want to pass the students the impression that what they are doing is hard, because they will believe it is hard and it will become harder than it is.
Okay, so I
Mm.
think I understand what you're going for. So, but here's my pitch. Here's the devil's advocate pitch. I think if you know that what you are proposing is something that has a little bit of a controversy, as a professor, as a teacher, I think it's honest that you say that out loud. So that's kind of how I interpret this. So he's saying this because he already knows that some people dislike. It's controversial, not that much, not that controversial, but a little bit controversial topic in the realm of C. So he's already pointed, making you aware of that, making you aware of that. Okay, and I did the same when I was teaching I/O and the decision to make effects within the type system. I told the students this is a controversial decision. You're gonna find blog posts with people crapping on this. I told them. Not
That's
because I am
fair.
agreeing with the critics, just but because I want them to be aware of what they are dealing with.
I suppose that's fair. I suppose that's fair. It's just, it's a because they believe it makes the code unclear. Like that particular bit is what all caught my eye when I was
Yeah,
reading it the
I
first time.
understand that. I
So
understand because you can interpret that as why are you showing me this if this has the potential to be unclear. I don't want to learn unclear code.
Mhm.
Come on. I understand. I understand. Anyway, so this is the upgrade of the eval op function, right? So this is just handling the operators and the functionality itself. And another thing to be aware that we didn't I forgot to point out last time. This is doing the checking of the parsing and the evaluation in a single line. So it may remind me a little bit of what Marinho loves with concatenative languages. that the parsing and evaluator are kind of fused together and they just go together. Because this
Yeah,
is the first time we were checking for the plus. Nobody knows what this is.
there is a small difference between reading and evaluating in the context of a concatenative language reader and reading and evaluation here.
I agree.
Because in the first case, we're doing that explicitly because we want to provide a metaprogramming facility that does not rely on second-class entities such as macros.
Mm-hmm.
But that's not what's happening here at all. The plus is itself kind of a second-class entity because it's just a string. It's not an actual function that you can
Yeah.
call. Like,
Yeah, pretty much. Yeah, I agree, but I just want to point that out because I saw this line and it's like, man, this could be anything. This could be like whatever garbage I want to type it down, and the parser will say, okay, that's fine. I'm gonna do a plus with that. uh, okay, so then we upgrade the eval function because the eval function is gonna use the eval op function. So I don't know about I looked at these three lines for quite a while. So if the C experts there, could you help me? So is this something that you're gonna import from like std error or something like that? And this is like a global thing that you can just set as to 0, and this function will interact with errno in order for you to do a check after. Am I understanding this correctly? Because I remember
yeah,
from Zosing streams that errno is a global thing that you can actually manipulate yourself, and some functions put their error meaning in the errno variable, and it's up to you, the developer, to keep checking the errno value. But I
uh,
just want to see if that's true.
personally, I'm not very familiar with this particular corner of C, or no specifically. But I will say that I don't like this approach. Like clobbering a global to report an error, that sounds like a
Doesn't
foot gun if I've ever seen one.
Go,
doesn't that
Margaret.
spit on the CDR?
Yeah, the std error. But if that's the case, why is it setting errno to 0? My understanding is to clean it up if if it has garbage.
Right.
Then this function may fail, and it's gonna do something with errno because this is what he cares in the next line.
I never used it, to be honest. I just saw. Uh,
std error is also
SDR is
a very
true,
common
right?
approach. Sorry?
Yeah, if I wanted to put like on SDR, like what does it do? That's my question. Like, does it spit like things to SDR? It's like a print, or what does it do? I don't know.
No, what he's doing is, my understanding is, he cleans it up, does the operation that may
Mm-hmm.
fail, and then,
Mm-hmm.
oh, let me check if the error node changed after this operation here, and if it did, I'm gonna do
Exactly.
an error or the value.
Okay, but
Because
you have to.
no works like a register for errors.
Yeah,
It's like the last error that happened.
yeah, pretty
But
much.
you yourself have to actively go and modify it, right? That's
No,
the
you have to
behavior.
clean it up. I'm assuming this function is modifying it internally.
Yeah,
Okay, but
it's
is that a
string
function he
2L
defined? That's what I'm
modifies it.
curious.
Don't you think it is
What?
a Linux thing? Like, does it even work in Windows or macOS?
Yeah, that's a
It
good
should.
question.
No.
It
This is
should.
safe from the standard library thing.
Ooh,
Oh, this is
Not
C, right?
Linux.
This is not
there.
depending on
If
the
the
like
converted
release.
Mhm.
value falls out of the range of the corresponding return type, a range error occurs, setting error node to this.
Yeah,
So it is.
it's kind
Uh,
of it's kind of crazy.
Kind of like a primitive exception, right? Something like that.
yeah, but it needs it's sanitary. You need to clean it up yourself. You need to prepare the surroundings.
Yeah,
Kind of
need to
crazy.
Yeah, because
dig the
because
grave.
because he's trying to return a kind of complex thing because you see it might fail, in which case it returns 0.
Hmm.
But it if it actually converts something and overflows, it has to
Tell you
also
this.
indicate that it overflowed,
Yeah. Yeah, but
and they chose to do like so.
these are the type of decisions that I don't understand the principle. Maybe somebody here has an insight. if I have a function that may do what I just said, what's the benefit of using a
Yeah.
global variable for that instead of just passing the reference of something in the function call? It's just to save
Allocation.
space. Yeah.
To have a standard,
Allocation.
maybe.
Ah, I see.
What?
Okay.
What did you say?
Marinho?
No, the alternative would be to declare a variable and give a pointer,
Yeah.
so
Yeah.
the function can write to
Yeah,
that
exactly.
register that you give it instead of using a global register,
Yeah, and
Mhm.
Marinho
I
said that
think that
this is
right?
done to avoid to improve allocation,
yeah,
basically,
to avoid an
Mhm.
allocation
to
actually.
avoid an allocation, which makes
Makes
Yeah,
sense.
sense.
probably.
Uh,
Hmm.
I
but how the
personally,
heck you
Well,
I
gonna do
personally,
parallelism? There's only one no.
yeah, that's
yeah,
very funny.
I personally
Yeah.
prefer the approach of I allocate a variable and I don't initialize it. I pass a pointer to it, and then there's no longer a global thing that everything will clobber. But that's just me.
Another alternative I can think is for standard, right? You don't want to just
Yeah.
pass a parameter there, so
Okay.
every
Uh,
function is the same way.
don't you think it is very different than the other functions and the standard? Like, for example, when working with scanf, the way you know if there is a problem or not is by checking the return value of the scanf.
Yeah.
Scanf will use side effects and change the contents of the variables you gave it, and will return how many variables did it change, and you
Yeah.
can check on that. So
Yeah.
maybe it would be better if they used this, but
And to
it is
complement your
strange.
comment, you can also use the null trick, which is that you always return a pointer, and if it's null, that means that there's an error.
But then in the always return a pointer thing, as I said, you have to allocate memory for that.
Okay, then Mac wins. So we
Yeah,
have
guys,
two ways.
yeah, because the function is trying to return two things. It returns the result of the conversion. So he needs to signal errors
Oh, okay. So there's a
somehow. You see,
Yeah,
this function is actually generating two results:
go
the
time.
actual conversion
yeah. No, this is
and
actually
The error
the error
information.
yeah.
signal.
This is basically
This
working
is
around the
this is why
fact
they have
that
to hack this around.
yeah, this is working around the fact that C functions must return 0 or 1 values. They cannot return any other number of results.
Yeah, and Mac, I found a problem with your
Yes.
idea. What if your function can actually return useful negative values, for instance? How are you gonna know it
Hmm.
break? It broke. Hmm?
Oh, you
Yeah,
can't know because the longs, they can be negative numbers.
No, no, no.
Mhm.
In this particular instance, yes, but Mac was suggesting, what about the other standard
Mm.
that people just return negative values to signify with the meaning of errors, right? So this is a
Mhm.
classic C thing. We return -1, exit -1, and stuff like that.
yeah. Lemos, the problem doing that here is that this is a string that's supposed to parse. This is a function that's supposed to parse a string and return a number,
No, no, no.
which
But
may
we are not
itself
talking
be
about this
negative.
particular example, Marin. This particular example is just one case. I'm talking more generally speaking.
Okay,
Um,
that's fair.
I
okay.
don't get it.
Wait. You didn't get it, Edu?
No.
Okay, so what we are talking about error handling or returning two
Hmm.
things in C. So candidate number
Yeah.
one, you have a global container that everybody has access to it and throws the error information there. It's called errno.
Yeah.
So
Yeah.
Mac pointed out that there is another convention to do error handling in C, which is that the return value of functions may be negative if the meaningful parts, the meaningful results of that function is only the positive values, right?
Yeah.
So then, if you
Which
get
is
a
not the
minus
case
one,
here.
yeah, which is not the case here, but we are just comparing the two error handling approaches that we have available
Hmm.
in C.
Hmm.
So this,
So there are
Counterexample of my approach is strcmp. If it is positive, it means
yeah, yeah,
bigger. If
strcmp,
yeah.
very
so,
Uh,
classic.
Yeah, so there are actually
maybe
two other approaches. Yeah,
Go on,
there's
Marin.
the one Max said, the one that uses Erno. There's the one I pointed out, which is you allocate a space in the stack or whatever, and you don't initialize it. You pass a pointer to that, and then the function can mutate the location that's already
Okay,
allocated. And
okay.
this kind of Yeah, this kind of gives you a second output without allocating memory in the function itself. That's the
Okay.
third option. The fourth option is actually to return a struct.
Yeah, but that sounds a little bit wasteful.
Why? You're trying to return two values. A struct can contain two values. Why
But
not?
if the struct is
But
not
if
a,
you allocate it, just sorry, Lemos,
mm,
but if you allocate something on the stack, how can you guarantee that it will be there after you return from the function?
You can't. That's why I mentioned passing a pointer to a memory region you allocated, because if the function allocates something internally, it will either have to allocate it on the heap, and then you're bringing in malloc unnecessarily, or the
Mm-hmm,
function
mm-hmm.
will return, and then whatever you allocated on the
you
stack is
lost.
gone, so the pointer is now
So
invalid.
what Marinho is saying basically, Ju, that you need to previously have something floating around that will survive when you return
Yeah.
from a function.
Okay.
Mm-hmm.
Yeah, you
Uh,
declare a variable and pass a pointer to it,
yeah, pretty
maybe.
much. And let me go back to the struct
Okay.
point. So if you are using a struct such as this one, and the fields are not pointers themselves, which that basically means to me that they are going to be zero initialized, and that means it's waste of space again.
No, it's not. Because you have to return your true value that you're returning
Yeah,
and the value telling you if an error occurred, right?
yeah.
You have to allocate space for both of them regardless, so there's no disadvantage to returning a struct.
If you don't have an error, I don't
Um,
have to allocate anything with the error fields. Those zeros are just wasting space.
But you have to allocate the error fields outside of the function and
Yes.
pass a pointer to it and then check it afterwards anyways.
Ah, okay. Okay,
mhm.
okay, I understand. I understand. Okay.
The only reason I would say I would have against the struct approach is that now your API is a little more complicated,
Yeah,
right?
the API.
Because the
The API
function
for the
the
function.
Yeah.
function is no longer just
Mm-hmm.
returning a single atomic value, so that may have implications at that level.
Yeah. Oh well, we live in the era of Golang, so we are always returning true values anyway. So who cares? Eh. Okay.
Well, if we care too much about memory in this case, we can use a bit set. Like for example, the first bit means either we have an error or not,
That's
and
a very
the
Marinho
rest
way of
are
doing
for
things.
values.
The only reason I don't suggest that is that you are cutting in half the range of possible values for the main return
Yeah,
value.
every single bit that you do for something that you are using to something else, it's cutting in half the amount of possible useful values. So that's, but maybe that's not a problem for your case. It depends on the domain. So anyway. So now he's executing stuff, and it's division by zeros, and that's it. And then this is where the faith and intuition comes along. So now he's saying, yeah, you may feel uncomfortable that I'm just throwing information at you when we're not actually reading the the let's say the bricks, right? That we are building our wall. We're not really looking at the bricks. And he just says, yeah, trust me, bro. It's gonna work.
Mhm.
I'm a
it's
little
it's gonna work.
ambivalent about this. Yeah. On one hand, I think that's a good point because whenever you're using a library, you almost never look at the internals of the library, right? You just have to trust that it works. So that's one point
Yeah.
in favor of it. The point against it is that this is supposed to be a book that teaches you C, right?
Yeah.
And
No,
the right attitude
I
in
have a comment about
general
that.
for programming is to try to figure
No,
out
but
how stuff works,
Yeah, but
which
then the
goes
question
against
becomes,
this.
Marinho, what is the level of how deep you want to go with your students? That's the question. So if you
yeah,
go
but
very
it's
deep, the student may feel that it's not doing a lot of progress, hmm? Because it's going to spend a lot of time with minor details. And some students get demotivated when they don't see that they are doing a lot of progress each lesson. So maybe the reason that he's doing it like this is because he knows that if I slow down the pace, people is going to drop off.
Yeah, which is why I feel ambivalent about this. Like, yeah, it could be better, could be worse, whatever. This is fine. I do want to point out, though, I really like this picture.
Ah, the picture is great. Okay, so Gio, you want to say something?
never mind.
Okay. Okay, so next time, so we went through all the established expectation for today, which is 6 to 8 and maybe something of the 5, and we did that. So next time we're going to talk about S expressions. S expressions, probably the only thing that Lisps and Silverware have in common.
Maybe not even that. It's just
Didn't you mention that Silverware's reader doesn't actually return consoles like list structure?
yes,
It
that's
actually
why
returns a proper
it is just
ASP.
AML, man. It's just AML with like parentheses, and that's it.
No, but that's no.
Yes.
But I'm confused. If the syntax of, are you telling me that the syntax of Silverware is not S expression based?
No, no,
It
because
looks
here's the
like
thing.
as
It
expression,
looks
but
like it, but it doesn't have the essential to make it like, for example, XML. You can say XML is is like a S expression, right? Because it is basically uh, maybe
the
they go in a
critical
different category, but
the critical part is that S expressions are a notation for data.
Oh,
There's
we're
a
not
mapping
treating it
from
like
the
data ever. So if that's the criteria, we are out of the window already.
yeah, like we would have
exactly
in silverware
exactly.
to handle things as lists, and then by handling them as lists, we have the thing everything in data, right? The functions and everything, and then we parse those, but we don't. It's
Yeah, but
just
this is
like
reminding me of the commander's debate that he said, "Oh, I already looked into the common Lisp implementation, and no, not everything are lists." So
the
I
one
think
I had started with with commander was list was the
The
teapot.
point the critical thing about S expression is not that everything is lists. Like closures hidden syntax has
Yeah, that's
maps,
why I said
tags,
XML.
vectors.
Yes.
That's not the point. The point is that the notation is for data, and the data is treated as code.
yeah, that if that's the criteria to acquire the title of X expressions, we are definitely not doing that. We are definitely not doing that.
Yeah, that's why I said XML could be. I don't know if they classify on everything, but they are just there to hold data, right?
Yeah.
Okay, so then we're gonna talk about S expressions next time. Oh, so this is where the mallocs come along. How fun!
Oh, he lists all the code he did on the
Yeah, no,
session.
and you already have the code. This is all the
Oh,
code.
okay. All right.
We already have the flake, the C flake, so it's very fine for me to
I
try to
thought
run
each
this.
one of you guys were making your own.
Lisp?
We might.
Yeah,
We might,
why not?
but
Why
I
not?
already have Salem to worry about, so I'm not gonna do this.
All right.
Yeah. Oh, he's talking about the concells thing.
Hmm.
Very interesting. And then a little bit more code, printing expressions, evaluating expressions. What is the next topic? Q expressions. I never heard of those.
Yeah,
Ah,
that's a
he
thing
invented
specific to
this.
this book. I think it's
Yeah.
meant to be.
A quoted expression.
Yeah, I think the name is actually meant to invoke the original Lisp papers M expressions, except instead of being a meta expression, is a quoted expression. Like I think
Mm-hmm.
that's kind of the idea behind the name. I haven't read that
Yes,
far
yes,
yet,
it is.
so I'm not sure what he's doing that couldn't be just done with a quote operator, but
He's
whatever.
doing something that is easier to parse. Just that.
Okay, I believe you. Okay, so this is chapter 10. Then we have variables. How long is this? Cyclic, function type. Oh, so this
It's
is where we
it's
have
it's quite
functions.
long. Yeah,
This is where we have functions.
environments and yeah.
Okay, so my proposal is chapters 9 and 10 for next week. What about that? You think one
Uh,
week for two chapters?
that sounds reasonable. These chapters are probably a bit denser as well, so
Yeah, they seem okay. This is kind of cursed. Okay, but this is not an expression. Okay, that's less cursed. Okay, okay, that's fine. Edu, Mageta, Mac, two
Yeah, yeah.
chapters, one week.
Okay.
Sounds good.
Yeah, for me that's fine.
Perfect.
it's fine for
Awesome.
me as well.
Uh,